Spinning is the method of forming sheet metal into hollow circular shapes by working the metal with a smooth tool over a symmetrical form called a chuck while revolving rapidly in a lathe. The tool may be applied against the work in three ways: entirely by hand, partly mechanically, and entirely mechanically. Spinning aluminum differs little from spinning any other metal, except it spins more easily than most, and you usually use higher speeds. The spinning lathe is much like the woodworking lathe, except it's built heavier, with heavy thrust bearings in the head to take up the considerable pressure required in spinning metal. The other principal parts are chuck, tailstock, work, tool, tool rest, and movable pin. The chuck may be made of steel, close-grained cast iron, or hardwood, depending on the quality and quantity of the work. Always keep your chucks clean and burnished. Spinning is one of the few trades where the tools are not standardized. Each craftsman is apt to develop a set that he likes best, with certain individual characteristics. However, in general, they may be roughly divided into three groups. Tools for laying the metal down against the chuck: a plain, rounded-end hickory stick, a roll-type tool, or the half-round, all-purpose steel tool. The usual description of this tool is half-round on the top side, flat on the bottom. But that's not quite right. As this big close-up and cross-section will show, the upper part is half-round, all right, but the bottom is not quite flat, but crowned, and this slight crown is important. The upper part for laying down the metal, the crowned underside for planishing. The second group are the beading tools, and maybe wheel type, or a sharp nose tool in variations. The third group is the cutting or trimming tool, and is usually a plain diamond-shaped tool. Spinners' tools must be kept smooth and bright. The more nearly glass-like they are in polish, the better job they'll do. They should be buffed lightly any time they start to drag, and touched with light oil. But so much for the tools. Let's look at the metal. Most spun products are made from the alloys which are not heat-treated. 2S alloy spins most easily of all. An aluminum manganese alloy, 3S, has greater strength, but may require intermediate annealing and deep spinning. Occasionally, 52S and the heat-treated alloys are spun, but they have to be annealed more often or spun hot. In choosing the blank, it should be remembered that the finished article will be slightly thinner, and allowances should be made in both gauge and diameter. The area of the starting blank should be equal to the surface area of the finished product. As the blank thins a little in spinning and increases in area, this will allow for necessary trimming. Now let's do a little spinning, starting with a simple operation. We put in the blank approximately in the center and clamp it there. With the lathe turning slowly, loosen the tailstock slightly as you hold a flat stick lightly against the edge of the blank. Don't have the blank too loose, or it'll fly out, nor too tight, or you'll bang up the edge. Pressing lightly against the edge centers the blank. Tighten the tailstock, and you're ready to proceed. With the lathe running, cover the blank well with lubricant before you start. Use the hickory stick to lay the blank back against the chuck to set it. Now you've got just that much extra grip to hold the piece in place. And then in progressive steps, continue to work the metal down on the chuck. This is done with a half-round all-purpose tool. You remember we centered this blank by holding a stick against it. Other methods are find the center, drill a hole, or form a dimple, and position the blank on the chuck. For the lubricant, on the smaller pieces, tallow is widely used, or a heavy grease applied with a dauber. For heavier gauges, use ordinary yellow laundry soap. Regardless of size, the work must be kept well lubricated throughout the whole spinning operation, after every few passes of the tool, to lessen friction and avoid scoring the metal. The speed of your lathe is determined by the diameter of the blank and its thickness. Peripheral speeds for spinning aluminum range from 1,000 to 3,000 feet per minute. Normally, higher speeds for small, thin blanks, slower speeds for larger or thicker ones. Handbooks will give you a chart of suggested speeds, which you will want to adapt to your own experience. Here are some general rules which apply to all hand spinning. 1. Better to operate the lathe a little too slow than too fast. If the speed is too great, centrifugal force will make the blank stand out from the chuck and require so much tool pressure that excessive thinning will result, if not rupture. 2. Grip the tool firmly. Rest it on the tool rest. Brace it against the fulcrum pin and hold it there firmly with your free hand for steady control, the point touching the work below the center. 3. Keep the tool in motion. If it is left in one place too long, it will cut a ring or groove in the surface. But if the tool is moved too fast in relation to the speed of the machine, ridges will result. 4. Work the tool back and forth in a short radius, and we mean short. The arc should not be more than an inch or two on either side of the pin. So move the pin frequently and keep the tool at right angles to the point of contact. Don't work the tool continuously from the center out. That will thin the metal to the breaking point. And avoid working the same spot over and over. There's a lot in leaving well enough alone. 5. Let your whole body do the work. Don't try to do it all with your arm. The right amount of body pressure for a given gauge is something you'll just have to learn by experience. If too much pressure is applied, the metal will wrinkle or the tool break through. 6. Learn the feel of your work. Feel the metal flow under the tool. If the metal becomes too hard to flow properly, its workability can be improved by heating it with a torch while the shell is rotating. Of course, the metal may not be fully annealed by this method. The annealing temperature has been reached when a soft pine stick rubbed on the metal leaves a brown char mark. 7. Always leave a narrow flange on the outside of the shell at all times, even up to the final trimming operation. And keep the flange headed the same direction you're working. Don't allow it to turn back on itself, or you'll never get it straightened out again. If buckles appear in this flange, get after them right away. If they are not too bad, holding a smooth wedge-shaped hickory stick called the back stick solidly behind the buckles, you can often work them out with the tool. If this doesn't work, the spinning should be taken from the chuck and the flange hammered smooth. After the breakdown operations are all completed, starting at the tailstock and working outward, a final spin is made to lay the shell tightly against the chuck. To trim and bead, the edge is first turned back slightly. Then the trimming tool is held lightly but firmly against the flange. The edge may now be rolled entirely over, using a beading roll to finish the job. To remove the finished shell, in case it sticks to the chuck, give it a once-over lightly with a planishing tool as it spins. Having thus seen the art of spinning in its simpler terms, let us look at some of its more involved aspects. Here is a shape that is too severe to form from a blank in one spinning operation. And this is how it's done. The original blank was broken down on 2 intermediate chucks. First, breakdown number 1. The next size chuck is substituted. Breakdown number 2. And now we're ready for the final spinning. And there you have it. Or if it's like this end of an airplane fuel tank, it was broken down first in 3 draws, in a regular draw press with simple ring dies, then brought to the lathe for spinning. The operator gets it well soaked. Because of the thickness and temper of the metal, he has a helper to add his weight to the spinning stick. Incidentally, because it has to be spun so near the end, a series of different sized tail blocks are used to provide increasingly better grip on so large a shell. So far, we have been considering hand spinning only. Remember, there are two other methods, semi or partly mechanical, and mechanical. The semi-mechanical method differs principally in the application of the tool to the work, it being controlled by two feed screws, the wheel to the left, moving the tool back and forth along the work, while the wheel in the rear moves the tool in and out, following the contour of the chuck. It takes less strength than hand spinning, but does require considerable skill. Here's the mechanical method. Movement of the tool is regulated by hydraulic pressure, the operator guiding its path by control levers. A variation of the mechanical method is shown on this giant spinning lathe that will accommodate up to a 7-foot blank. In this case, the tool is a steel shoe applied to the work by mechanical pressure. When finished, this will be part of a giant sphere for an electrical laboratory. Here is still another type of spinning, called shoe spinning or burnishing. The shells have been drawn to the desired shape in 2 or more draws. The drawing operations have left the surface of the shells slightly ridged and roughened, as seen here in magnification. Slipped over a polished steel chuck, the shell is held in place while being trimmed, beaded, and then burnished by pressing against it a hardened steel burnishing shoe with a highly polished surface. Burnishing produces a uniform, smooth surface. The operation reduces the thickness of the metal slightly and increases the depth of the shell very slightly, for which allowances must be made in the draws. Most of the chucks we've seen so far have been made in one piece, but for a job like this tea kettle, where the metal partially encloses the chuck, it is necessary to build it up in wedge-shaped sections with one straight-cut segment or key. It may be made either of hardwood or tool steel, but in either case, it must fit perfectly at the joints, for the slightest irregularity will be impressed in the spinning. Here's another type, the off-center chuck. After an initial draw, the shell is slipped over the spinning form. Being off-center, the form comes in contact with only part of the shell, the remainder of the surface riding free. But you cannot spin the entire length of the shell, since part of it is enclosed by the chuck. The shell spun by this method can be taken off without dismantling the form. One more method that requires more than ordinary skill is known as spinning on air. No spinning form is used at all. The shell is spun without support, although at times a hardwood wedge may be used to back up the work. Here is a mechanical variation of spinning on air in which an idler roll operates against the metal immediately adjacent to the supporting sleeve and takes the place of the forming tool. A machine such as this is particularly well adapted to the formation of straight or irregular tapers in tubular sections. Even baseball bats and lamp posts are made in this way. And now, checking back over the points in particular to remember, always keep your chucks clean and burnished. Likewise your tools, a glass-like finish at all times. Use plenty of lubricant. Coat the blank with it before you start, and every little while during the operation. Adjust the speed of your lathe to your work. Use your whole body and learn the feel of your work, the flow of the metal. Keep the tool moving in small arcs, back and forth, not always in the same direction. Do a smooth job and learn to let well enough alone.